Hello and welcome. So, consider a hyperbola which contains the following vertices at negative 7, 7 and negative 7, 3, and a foci, one of your foci, at negative 7, comma, negative 5 plus 2 square root 5. Alright, so first thing you gotta know is a couple of things. You gotta know the orientation of your hyperbola. Are you going vertical or is this horizontal? Well, we can easily tell that by looking at the information we're given, right? We have one vertice at negative 7, negative 7, and the other one is at negative 7, negative 3. What changed between these two? The y value, right? The y value went from negative 7 to negative 3, meaning that if you're changing in the y's, this has to be a vertical hyperbola. Because remember, the vertices are the turning point of each curve, so it's at negative 7, and then one's above, and one's below. Okay, the x value stays the same, right? Same x value, the only thing changing between them is the y values. So we have a vertically oriented hyperbola. Okay? Perfect, right? That determines the equation straight up, right? Remember, in order for the equation to essentially be a thing, if it's vertical, that means your y term is positive, and your x is negative. Alright, so this is a equation for a vertical hyperbola. If it was a horizontal one, all you do is you would essentially put this first, so you have x minus h squared over a squared equals, not equals, subtract, y minus k squared over b squared equals 1. This would be a horizontal hyperbola. This is your vertical. Okay, so all it does is that whatever is positive is the direction you're going, right, and then whatever's negative is whatever direction is positive is the one you're going in, right? And then the one you're not is essentially the negative. Okay, so now that we know the equation, we know our direction, let's start filling in some information here. First off, we got to know three things in order to write this equation. You got to know the center, you got to know your A, and you got to know your B. That's an awkward B. There we go. B. Alright, center is going to be smack dab in the middle of your two vertices. Always, whether it's horizontal or vertical, it's always in the middle of your vertices. Okay? So where this one is going to be on the same x value as the other ones, we already know the h, right? The h is essentially just the x value of the center. So the x value of all these is negative 7. That means your center is going to be negative 7 comma something. And then all you have to do is just find the middle of your two y's. Well, we know the y is at negative 7 and negative 3. So that means if we combine them and divide by 2, that should give you the middle. Negative 7 minus 3? Negative 10. Half of that? Negative 5. Bam, center, negative 7, negative 5. There is your, half of your equation, really, because we know the center is h comma k, which means your h is negative 7, your k, negative 5. So we just said our h was negative 7, and our k, whoops, let me do that a little bit more, our k, negative 5. Okay, and now you can polish this up a little bit, obviously, right? If you subtract a negative, that's the same as just adding it, right? So you can add 5, add 7, and there, bam, halfway. Now you're just going to find your a and your b value. And this one's not too bad either, because if we know the center is at negative 7, negative 5, let me start writing some of these out. Negative 7, negative 5, right? And this one's at negative 7, negative 3. Okay? Then essentially, B is the distance between your center and your vertice, because it's a vertical hyperbola, right? Which means that the vertice is going to be the main distance there. It's your B value. And then your covertice, right, is going to be the A value as you go to the left and right. Okay? So from there, you could say, all right, well, now we know. Because how do you go from negative 5 to negative 3? What's the distance between those? 2, right? If you have negative 5, add 2, you get to negative 3. That means b is 2. Okay? So if we want to find b squared, all we have to do is we know our b value is 2, so if we square 2, we get 4. So, bam, 4. Okay? Now we got to find our a value, and how we do that is we use our Pythagorean relationship for that one. For this one, it is a squared plus b squared equals c squared. Very reminiscent of your Pythagorean theorem. We call that, it's Pythagorean relationship, but for hyperbolas, it's literally just your Pythagorean theorem. Okay, now for the foci, why we use our Pythagorean theorem, what we're going to use is that how you find this for a vertical hyperbola will be your h value and then k either plus or minus your c. Okay, we know the h and we know the k, right? We just literally found it to be -7, -5, which means your c value is this one right there. It's 2 square root 5. That is your c value. And we also know our b value already, right? Our b squared value is 4. So that means we know this one, and we know our c value is 2 square root, what did I say, 5. And then that just leaves the a squared as the only unknown. So that's why we use our Pythagorean relationship, because when we use our foci, we know that third value, our c value, and we can back solve for it. Okay, so then from there you would square your c value because it's c squared. So then you would have 2 squared because it's distributes because of your exponent property, only because there's multiplication there. Addition and subtraction, that wouldn't work. So you have 4 times squaring the square root just gives you 5, and then 4a squared plus. Okay, so then we get 20. All right, 4 times 5 is just 20 there. So subtract 4, and we get a squared equals 16. You don't have to solve for a, we know it's 4, but we need a squared in our equation, so we would just put 16 in its place, and that's it. You have now written the equation for a hyperbola. Huzzah! That's all there is to it. Thanks for watching.